It's sort of like electrons that aren't connected.
Okay. So this is
And
kind of, all these are kind of just definitions type thing.
well, yes. So the
Okay.
tetrahedral comes from how many of the lines there are for a tetrahedral. Nonpolar is because I think this balances out pretty nicely.
Okay.
Whereas you'll notice, well, we'll get to that. Maybe you are supposed to know some of the polar and nonpolar. Let me look that up here. So it says when so polar, I'm not sure.
No, that's totally fine.
But I looked this one up and it
Oh wait,
said
I think oh wait.
this one said it was nonpolar and I looked it up and I don't have a good answer for why that is. So,
Oh, it says if all the bonds in the molecule are non-polar bonds, the molecule is non-polar.
okay.
But what does that even mean? If the bonds of the molecular are polar, the symmetry of the molecule matters. Here are some examples, and then it like shows.
Sometimes we'll just keep going and see if we
Okay.
can,
Okay.
get
Yeah.
one that makes a little more sense to get something from.
Okay.
All right, so the next one here is H3O plus. So you've got O in the middle again. You got O in the middle. And then, sorry, I'm going to get where I'm backed on the screen. Okay, so this one's awkward. You've got the O, you've got an H, and you have the other H's here. But you have kind of a problem because of this +1, which I haven't really seen of, but I believe that they sort of want you to indicate that okay, in terms of this is +1, this is -4, but there's like a missing, you got 3 +1s, that's +3, -4, that's where the +1 comes in. And they want you to, I don't know if you need to indicate it that this is like a plus, maybe that's in your book somewhere.
Okay. So wait, why did you put the O in the middle?
You put this kind of the one that's general rule is like this one with less, or there's only one of them, it goes in the middle.
Okay. Okay. So whichever one doesn't have the number next to it, kind of.
Yeah. So
Okay. Okay.
if it's just singular, it tends to go in the middle. And it
Okay.
does
Got
look like you're supposed to put this plus here because of the ion there.
it. Okay.
Okay. Now there's 3, what's the right wording they're using there? Bonded pairs. Yeah,
Bonded pairs. Okay.
three of these lines. And then there's one that's not bonded
Okay.
up
Yeah.
here. So that's
Okay.
that goes there. And then we can't do
Yeah.
that one, but this is called a trigonal pyramid. And this is pure definition stuff, trigonal pyramid.
Okay.
And I just looked this one up. It is polar.
Oh yeah. You can also just look these up.
Yes.
Oh.
Well, yeah, I mean, there's
Oh.
a, takes a while, but yeah, this water is polar.
Oh,
It's
okay.
it's kind of a known one. This is a variation on it. It's some sort of trihydrogen, trioxide. I don't know. It's something.
Something.
Yes. Okay. Any questions on that before we move on to the next one, H2O?
No, I think I'm understanding it.
Okay. All right. And this is
So,
kind of the flow of the lesson. You'll see.
okay, wait. Can I try the next one? See if I'm right.
Sure.
So O would be in the middle,
Okay.
and then the 2 H's would be like on the side.
This one it's like a known bent structure.
Okay.
Uh, something to do with the way water is. It's bent a little bit.
Oh, okay.
So, um,
And then the number of the bonding pairs would be 2, and then the other one would be 0.
two, because there could be like, they're not shown, but there's up to 4 around it.
Oh,
So
okay,
these tend to add up to 4, tend
okay,
to. Lord, we're gonna see an exception at some point.
okay. Then can't do that one. The name of the shape.
This is bend, and water is polar.
Okay. And then
So you got
HF.
HF next, yeah. So when they're both singular, they go side by side. So it'd be like an H to an F. I don't know if the order matters. It's one of those nuances, like I just don't know.
Okay.
And there's just one line between them. If you look on the periodic table, I think H wants to lose one and F wants to add one.
Okay. Yeah, I'm like I have to like look at the pyramid. I don't even know what that is.
And just remember, do you have tests in person or is this all
No,
online? It's all
online.
online.
Thank
Okay, and
God.
even the tests are online.
Yeah.
Okay. So, I mean, we don't necessarily need to have a lot of justification here for why this is,
Okay.
because is what I'm hearing. And I'm maybe not the right person to do that, but
Nope, that's
uh,
literally no, that's fine.
so there's one bonded pair and 3 unbonded.
Okay.
This one is considered linear, and it is also polar. Probably something to do with the fact that it's an acid.
Okay. Do you know how on like Word how to add these diagrams in there?
I do not. I would suggest printing it and or typing in everything but the
Honestly,
diagram.
yeah, I think I'm just gonna print it. It's just so much easier. Yeah. Okay. The CL2.
Next one is CL2. Yes, this one's a little bit different because they're the same.
Okay.
CL and then CL. Uh, I don't quite understand this first part, but we'll talk about it. So there's CL and then CL. And there's one bonded pair between them. So I
Okay.
would think that there are 3 unbonded pairs, but
Wait,
it's like,
3 said?
yeah, 3 again, it's kind of like this one up here, but what I was wondering is I'm seeing some things about electron configurations, but I guess I would go with 3. And
Okay.
this is again linear. And then if you look, believe this is nonpolar. And I'm looking up some of these as we go on
Okay.
to better assist here. Um, give me just a moment, please. Right. So we're up to NH4. This one's a lot like this first one we did. It just doesn't have this one has the added ion with it,
Okay.
um, which just means it's the chart that it's out of kind of balance with the charge. But you put that
Is it-
N in the middle,
Okay.
and then you just go all 4 directions with the H's here.
Got
But then because it's an ion, you have to put a plus around part of it.
Oh, so it's like the exact same as like the other one.
It kind of is the we did one earlier. This has
Okay.
4 bonded pairs. There's 4 of them there, 0 unbonded. It's
Wait,
tetra.
wait, why wouldn't it be one?
The sum of these is 4, like, because there's 4 of these lines.
Oh, okay.
This first number always always indicates the number of lines here, which there's
Well,
a, they're really like electrons that they're sharing, but you draw them as a straight line.
okay, no, but I'm saying like the +1, you know how like up there we did one bonding
Yes,
pair? Why is it 0 instead of 1?
there were only 3 lines here. So there's three bonded, 1 unbonded. The 1 unbonded's like up here above the O.
Oh, okay,
Like this first number is just whatever you've got here. These 2, these 1.
okay.
And then let's see, NH4 plus is polar. Nope, I'm sorry, it is non-polar. Maybe we can spend a little time about that. We get through everything
Okay,
talk about. So NH3 is neck, looks like.
yeah.
All right.
So it would N be in the middle and then the 3 branches things.
That'd be, and I don't know if it matters like whether you go down or up or left or right. I don't think it does. But
Okay.
you've got three there and then 1 there.
And then what, so I think I'm confused on the non-bonding pairs. Like
The
how do you know what a non-bonding pair would be?
Yeah, so if you look at all the ones we've done,
Okay.
the number of bonded pairs and unbonded pairs adds up to 4
Oh, it always has to add up to 4?
for most things, yes. And it has to do with the fact that there could be 4 of these lines because they're sharing electrons is the idea. But yes, they add up
Oh,
to 4, 3 and 1, 2 and 2, 1 and 3. The first one comes from the actual number of link between them, shared paired electrons.
oh, okay. I get it.
All
Okay.
right. So keep going here.
Wait, did
Uh,
you say, oh, sorry. Can you go up one more time? Was it
sure.
linear? Or wait, I think I,
4 is
oh wait, never mind.
tetrahedral.
I did that. Okay.
So NH3 is trigonal pyramid.
And then,
This one looks like it's polar.
should I study like the periodic table, do you think, or do you think that I'm fine?
Well, yeah, are you taking another class after this that's based on?
No, this is chemistry and I'm done after.
No, I mean, I would limit your exposure to just the things that
Need to
yeah,
do.
yeah, I mean, this sounds like just you're doing it to fulfill a requirement, and
Yeah.
beyond that, I mean, the things that you'll take away from this course that I think you might use in another course would be like conversions, like milliliters to liters. I mean,
Uh-huh.
you're not going to be asked to write unbalanced equations.
Okay.
Um, you may want to be more familiar with things like what's an acid and a base, or what's a salt and a
Hmm.
non-salt. But I mean, healthcare is so regulated. I don't think they're going to let you. I mean, the things that I mean, when you take your nurse's exam, whenever that
Uh-huh.
is down the road, I mean, that's when you're going to brush up on anything you didn't learn or remember.
Yeah, okay.
I don't know. It might be worth looking at that, looking at some of those questions now just to see what you're in store for. But I,
Uh-huh.
I I think what most students do is they just get a few books and they study their butt off and then they pass it.
Okay, sounds good.
All right. So the next one here is SO4 2 minus. This one's a tiny bit different because it's 2 minus, but there's an S in the middle. O, 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 and O. And then
Okay.
I think you just put the 2 minus, for example, here, or -2.
Okay. And then it would be 4. Would it be like 4 and 0?
Yes.
'Kay.
Exactly. And then this is tetrahedral. And it is also nonpolar.
Okay, perfect.
All right, so the next part of the lab appears that they want you to use this software, but I think we can do it the kind of the same way. It's asking for the same information.
Okay.
Although this one does say screenshot of molecular structure from moleview.org.
Oh.
If you want, I can spend some time right now clicking on it, maybe helping you. It might be easy to use. I have no idea. What would you like me to do?
Um, hmm. Let me click on it and see what it looks like. Yeah, so do I just like put in where I
I've
think
never used this before, so I have no idea. I'm trying to figure it out here on the other screen.
yeah, I have no idea what this is. If this is too confusing, I can just ask one of my friends to help me.
Well, I like I said, I can spend a few minutes trying to figure it out with you. I
Okay.
can share that screen and we can try to look through it. Otherwise, we
Okay.
can just draw the structures kind of the same way. I don't know how. I mean, you've got to have something, I'm assuming, for this. I mean, do you think you're going to be? Are you going to be graded on? Okay, you didn't have a. Um, do you need a screenshot, or do you think you'll get marked off for that?
Yeah, I probably need a screenshot. I can
So
just
there's
I can just honestly ask I can just do it with my friends and we can figure it out.
sure, whatever you
Yeah,
would
that's
like.
fine. Um, okay,
All right,
what
let's go down to nitrogen then. So part 2 data table, you see it's the same thing here as before. So we'll draw the dot structure, and then we'll bonding pairs, non-bonding pairs, you name it, shape, polar, non-polar. So pretty much the same thing we just were doing. No big
okay.
deal. Oh wait, are there
Oh
discussion?
wait, it
Are there
says for each molecule in part 2 data table, you will complete the following. So is this just oh wait, it's just the same except are these the ones where I have to screenshot all these
yes,
all these
yes,
four?
yes.
Okay, so we can just do the rest besides the thing. Okay.
Sure. Um, got that. And then, I mean, are there discussion? Okay. Then, so there's also some discussion questions at the end.
Yeah,
Um,
I can
good.
do those probably.
Okay. All right. So let's take a look here. So we've got nitrogen, and this one's a little bit more complicated. So I don't know how you're supposed to know this. That's probably why they want you to so this time it has 3 in between and then 2 electrons on the outside.
Okay.
Again, I'm not sure how you are supposed to know this.
Don't worry, I'm gonna go back through this, so it's fine.
Okay.
And
So
then
this has 3 bonding pairs. Um, and then this next one's a little bit different. It says number of bonding non-bonding pairs off central atom. You can't. And I think it's because these are the same, like these are both bonding pairs, but they're unbonded.
Okay,
So there's actually two. So just like everything else, nothing is like perfect, always works.
okay,
So I know that that's inconsistent with what we just said, but 80-20 rule works for most of the time.
sounds good. Name a shape.
So this is a linear again, just because when there's two, 1, 2, they're side by side, it's linear. And then if
Okay.
you look it up, it is nonpolar.
Okay, next one.
The next one is nitrate. Nitrate here. Let me snip this in. The kind of the same deal. You put the N in the middle, the O, the O. Well, I guess I like to do it. O, O, and O. But this is -1 now.
Yeah,
Okay, so now there are three there in the middle. With the O's on the outside, this is where I guess it gets a little different. I'm trying to remember why this is. That's my continuous struggle here. Is like each, I want to say it's like each O is missing. Like you could, like, let's just say the O down here on the bottom, it could attach to something else, but they're not there.
okay,
And I think this comes from that mole view structure. Like I can't be sure
uh-huh,
that like, but the, um, let me just check one more thing. Yeah, so this is kind of so there's actually, this is why I need to look this up. There's actually I'm sorry, there's two on one. Okay. This one's more complicated. There's two on one of them, one on the other. Okay. But then, like I said, each of these, there's three that are missing down below here. And then
okay,
there's 1, 2, 3 here, but only two here on that one because it's already got the two. So 2, 3, 4, 5, 6, 7, 8. So there's actually 8 unbonded there.
okay.
And this is actually 4 in the middle. So I had to look this one up again. Okay.
No, that's fine.
That mole view probably tells you all this as well. That's be nice to know that. But okay, so we got a trigonal pyramid again,
Okay.
I believe, because it's
So is it every time it's three, is it just the trigger, whatever?
yes, I believe so. Let me just double check that. Yep, trigonal pyramid,
Yeah.
and then this one is nonpolar.
Okay, and then the next one,
Sulfur dioxide.
2 and 0.
Okay, so start with S in the middle, O and O. All right, and let me just, I don't like this one. I don't know why it's doing it this way. So there are two there,
Yeah.
which doesn't seem right. Let me check this one. Yeah, so this one's double bonded here, which makes 4. And then again, there's kind of these missing ones. Sorry, there's only 2 missing ones,
Okay.
top and bottom. around each one is possible of 4. So around the S, there's 4, but then there's 2 missing ones there, 2 missing ones there. So that's 4
Oh, got it. Okay.
in that one. And then this one is, well, I believe it's linear. It's saying it's bent. I don't understand why. So this should be drawn slightly different. So it really should be kind of S O O like that. And bent are always polar molecules.
Got it.
Carbon dioxide's the last one here.
Yep.
Does that look right? Okay.
Yeah.
Sorry, it's just too many things open here, trying to get us all synced up.
Oh, no, you're fine. Sorry, this isn't, I didn't even open this, so I didn't know this wasn't math.
That's okay. Happy to help. All right, so this one is linear. Carbon dioxide is in line here. This is one of those things I just don't understand about chemistry. I don't feel like it's clear why this is the case, why that previous one is bent and this one's linear. I'm not sure. Chemistry
Yeah.
person would know. There are 4 though around there. But these O's around here, they're missing. They're missing top and top and bottom because
So
you can go,
4 again.
yeah, 4 again. Like I said, linear, and then
Um,
CO2 is nonpolar.
Perfect. Um, okay, I'm looking at the other question.
So we got some time here. If we can go through the discussion questions if you would like.
Yeah.
All right, let's do it.
I think this is just a definition. Why are the double and triple bonds necessary?
You're not seeing the what is a covalent bond? Maybe I.
Oh yeah, I saw that. I just think that I can just find that on the
Oh, okay. So yeah, which one do you want me to start with? Number 2, number 1. What would you like? We got
Yeah,
10 minutes left.
yeah, we could do number 2.
Okay.
Why are double and triple bonds necessary in some molecules?
Yeah, so we saw a few examples of that, and it really comes back to um the charges and the valence electrons. So let me just kind of type an answer here.
Okay.
The answer is based on having enough valence electrons to fill the outer shell. Okay. So the idea is like, okay, so if they're, say, so electrons are shared when there is one or more what are called lone pairs of electrons
Okay.
in the outer shell. It
Okay,
just comes down, it comes down to how many electrons they have to share because the bonds are based on that.
okay. Okay, that makes sense. What else should we do? Okay, maybe number 8.
Okay? So these often refer back to like what was in the lab. That table, we would want to like go back and say, okay, like what were the same, what was different? And yeah, this is H3O plus, this is NH3 molecules. So I'll bet if we look back, their structures are similar. And we'll see that here. So let me just do a quick check. So if you go back in the table here, I believe you'll
Uh-huh.
find that they're both polar. Sorry, did I miss H3O plus and NO3?
I think, yeah, it's up there.
Yeah, polar and polar, and they're both trigonal pyramid.
Oh, okay.
So I think that's like a sufficient. You can say
Answer.
they're both polar and they're both trigonal pyramid.
With the H's having 3 bonded pairs.
I mean, that's one, that's two. You can add more, I suppose, if you want.
Okay.
Less is more when you're, in my opinion, but I'm not great. So,
Okay. Yeah, that's fine. Okay. I'm gonna have to look at what ISO, whatever. What about number 12?
okay. All right, when looking at a Lewis dot structure, what are two pieces of information you cannot determine with the Lewis dot structure alone? So they're trying to tell you, like, what can you not figure out that, it does not tell you, this is just a definition, the total number of electrons.
Okay.
It just like, for example, we looked at one where it was like, I don't know, H2O, that's probably the easiest one.
Okay.
Like we don't know how many total are here. We just know that they share.
Got it. Okay.
Second thing is how the bonds form. I think that means like who's gaining, like gaining versus losing
Okay.
electrons. We don't know. We just know that they're shared. We don't know like when they break apart who's going to get one or who's not going to get one.
Okay. That makes sense. So we don't know which what how do I say it? Which bond is gonna gain or lose an electron?
Like we don't know if hydrogen lost one or gained one or oxygen lost one or gained one. We just know that they share them. They're just, it's
Okay.
like when you live with someone like a, in college you have roommates. It's like, well, whose couch is it? It's like, I don't know, we share it, but then everyone moves out and then it's like someone takes ownership. We don't know whose it
Okay.
is.
Yeah. Okay.
Sorry if
Well,
that hit too close to.
no, that's actually such a funny example.
Yeah.
Okay. I don't know what else to do.
We
Hmm,
got 5 minutes left if you want. I mean, this is kind of the structure of the lessons.
let's see.
I'm happy to help, with these questions or whatever you want. Obviously, I would love to do math stuff, but there doesn't appear to be any, so
Yeah, sorry.
it's okay. Do the best I can. I mean, if you wanted like the pure chemistry knowledge, there are people out there that specialize in this, and I don't. But you may not get what you're looking for, which is just to help getting through it as well.
Honestly, no, it's like fine. I think I just need to look over the lessons. Like, I think I just need it because there was like the previous one, there was a lot of math in like
Yes.
the conversions and like all that. Like there is like a lot of math. I guess this one is just not.
No, it comes around in chunks and then goes away for a while.
All right, well, maybe we could do which one is like there's not really math for it.
No, it's okay. I'm gonna keep
Maybe 7.
sure.
Wait.
You have to cite any of your answers,
Um,
citations or anything like that?
yeah, we can't yeah, you can cite them. I think you are
Okay.
supposed to actually.
Just be careful. I'm not copying and pasting from the internet at all. Just always be careful though. Like
Yeah,
when you like if you write down what I'm saying, I mean, you should be okay, but just maybe cite and in any way just to be safe.
yeah.
Okay, explain the difference in polarity between CO2 and SO2 based on their molecular shapes. So we got to go back and look at the molecular shape. So CO2 is linear. Sorry for all the scrolling. CO2 is linear. That means it was in a straight line. And then oh, I didn't grab polarity, sorry. Oops, going on. Non-polar. And then I believe SO2 was bent.
Mhm.
So you have the S, O, and this was polar. Okay, so the simple answer here is that if the bonds are symmetrical, then it is non-polar. And you can think of that as the linear, that's
Yeah,
the first one. And if they are not symmetrical, which is the bent one, it is polar.
okay. I wrote if the bonds are symmetrical, then it's non-polar, and if they're not symmetrical, like the bent one, it's polar. CO2 is linear, which means it's in a straight line and non-polar, and then the SO2 is bent in the shape. Wait, that just doesn't make
That's
sense.
it.
Okay.
All right.
Okay.
Okay, if we stop here for today.
Yep, sounds good.
All right.